1/4 of the students in Mrs. Singh's class choose guitar as their favorite instrument. 1/4 of the students, and there are 24 students in the class. So the question is, am I frozen? No. I might have disconnected though. The question is, hopefully I'm back in business here. Am I back in business? Yeah. Okay, so the question is, there's 24 students, 1/4 chose guitar. How many students choose guitar? That's the question, okay? So we know there are 24 and 1/4 chose guitar. You don't have to write all this down, okay? You're just kind of setting up what you do in your head at the beginning of problems, right? And what you need to find is how many students choose guitar. Now, you could have done this problem as a fraction operations problem, but we're going to talk about it with percent. Okay, so we're going to use this bar diagram or a strip, okay, to represent the situation. The bar diagram represents 100% of the class. 100% is the total. 100% is always the total, okay? So, and we are going to show, we want to know what 1/4 of the class. Now, what percent is 1/4? What is 1/4 of 100? 25. That's one you're supposed to kind of know real easy off the top of your head. 25% is 1/4. 1/4 is 25 cents. Right? That's kind of how you remember that. 1/4 is 25%. Okay? So we split this 100% strip into 4 equal parts because each one is 1/4 or 25%. Well, then I'm going to use a strip to represent all the students in the class. That's 24 students. Okay, so there's 24 students in Mrs. Singh's class. And I'm now going to divide that number of students into 4 equal parts. So 24 divided into 4 equal parts means that each part is how many students? Roman? 6, correct. Okay, so each block here, each piece of this strip is 6 students. That means that each box that's 25% is the same as 6 students. So 25% of the 24 students in the class is 6 students that choose guitar as their favorite instrument. Okay, so what we're doing here is we're making 2 strips, one of them to represent the percents, it goes to 100, the other one that represents the total amount of things. And then you split them up into equal parts, and you can visualize what the percent is. Okay, so here's another example. 500 7th grade students at Heritage Middle School. 60% of them play a musical instrument. So I'm looking for where the total is. That's going to be my 100%. Right? That total is 100%. And then what is what I'm looking for? Okay, that I want to know what 60% of that group is. Now, there's 2 choices in how you're splitting up your percents in these problems. One is to split them up into quarters. Okay, but this one, if I want to calculate 60%, then I'm going to split this percent strip up into 10 equal parts. Each part then would be what percent? If I split this strip into 10 equal parts, each part is going to be 10%, 100 divided by 10. Okay, so if I do the percent strip in 10 equal parts, each part is 10%. The student strip, the entire thing is going to represent how many students? The entire strip of students, it represents how many students? $500, exactly right. That's the total. The total amount of students is the same as 100%. So if I split the percent strip into 10 equal parts, each one is 10%, I'm going to split the student strip, 500, into 10 equal parts. And what is each one of those parts going to represent then? What is each block here, how many students is that in each block? What did you say? So I split 100 into 10 equal parts by doing 100 divided by 10, and that gives me 10%. So Kenny? 50. 500 split into 10 equal parts, right? So each part here is going to be 500 divided by 10, which is 50 parts. 50 students. So each block on the student strip is 50 students. So every 10% is 50 students. Now I can look at what the question is asking. And the question is asking, what is 60%? Okay, so then I'm going to take my first bar here of percent. They make you write all these things over again. Every step here in the book is kind of annoying, isn't it? Sorry about that. And because we already did all this, right? That's 500 total students, and each strip is 50. So 60%, I'm going to shade in 60%, 10, 20, 30, 40, 50, 60% on the percent bar. And then I'm going to shade in the same number of blocks on the student bar. 1, 2, 3, 4, 5, 6. How many students is this? $300. 300 is correct. 50 times 6, 300. Okay? Which means, since 60% is 6 sections, okay, then how many students are there in 6 sections? And the answer is 300. Okay? So this is how you use a strip model, okay, or a bar model, to visualize what the percent means and then what the actual number of your total is. 2 more examples here. Okay, so there's 2 questions here. Question A is the 8th grade question, and question B is the 7th grade question. Okay, because they give you both numbers in here. Okay, so 8th grade and then 7th grade is even a little bit different question. All right, go ahead and work on the 8th grade question. Okay, if everyone was here in class, of course, I would walk around and see how everybody's doing on this problem. But those of you that are at home, I can't do that. So I can only assume that you're going to work this problem at home and ask questions if you have them. My camera is focused on Matt, working very feverishly hard here. Just do, well, you can do letter B if you get past letter A, but we'll do B together. Absolutely. Okay, so remember, you take the 100% strip, and you, on the other strip, which is tickets in this case, what is the total amount of tickets that you're going to set equal to that 100%? And then split the percent bar into the right number of equal spaces. It's either going to be 10 or 4. If it's a 25%, 75%, you would split into 4 equal spaces. If it's some kind of 10%, like 30, 50, 80, then you would split them both into 10 equal pieces. The first box that you should be filling in is the little box that's underneath the 100%. That's that number is an important number. That's the total number of the goal, right? Yep, that's very good, Matt. You're looking good. How you guys doing back here? Okay. What goes underneath that 100% in that box, the little box on the ticket side? What goes in there?
30?
No. It's the total number, right? 100% is the total that you are looking for. And so for the Is that for the 8th grade? This problem is for the 8th grade students. So the 8th grade has a goal of selling 400. The 7th grade is 300. So if you read carefully. Okay, then you're going to split each of those strips into how many equal boxes? You're looking for 30%, 10 equal boxes, right? Each box then is going to be 10%. How are we doing there at home? Okay? Thumbs ups? Thumbs down, Nate? Nate, do you know what number goes under the 100% there in this problem? Do you have your book? Okay, okay. What number are you going to put in that box there under the 100?
100.
400, that's correct. 400, the total number of 8th graders. My blood appointment.
Hello, this is the American Red Cross calling to remind Daniel of your commitment to donate blood. Right now, there's an urgent need for type.
I have an appointment tomorrow to give blood.
One patient received a positive blood transfusion
What?
in the other blood type. The Red Cross urgently needs to help with donors, and other blood shortages.
Yeah.
Generous donations help ensure doctors.
Yeah. Get to the bottom of it. Okay, so how many spaces are you going to split your strips into, Nate? How many equal blocks? Both strips will get split into how many equal blocks?
3.
Well, if you split it into 3 equal blocks, each one would be 1/3. But we're looking for 30%. So if percent is something that is a multiple of 10, we're going to always split that strip into 10 equal blocks.
I'll go get one of my papers on I would love to call it Kim.
10. Someone at your house, Nate? Little sister? Little brother?
My sister.
Oh, okay, yeah. All right, so.
I can call it later.
Here's what this should look like. Okay, so the total, again, identify the total. So for the 8th grade class, the total is 400 tickets, and you're looking for 30%. Okay, so the total is equal to 100% always. So the bar of tickets, the entire thing is the same as 100%, so that's 400. Since this is 30%, we're going to split this into 10 equal pieces. Because 30% is going to be 3 of these. That's 30%. Okay, and so then the number of tickets also has to get split into 10 equal pieces. And how many is each block going to be worth, Matt? 40. 400 divided by 10. Split 400 into 10 equal parts. Each part is going to be 40 tickets. Okay, you do not have to write all of these in when you do these problems. Okay, you're actually going to do these on IXL anyway, so you don't have to write it in. You just have to shade the parts. So 30% then, 30% is going to shade the same amount of the tickets as the amount that was shaded in the percent strip. So that means it's 3 of these 10%, 3 of these blocks of 40, which means that they sell 120 tickets. Okay? Now the 7th grade, they sold 60% of their goal. And the question is, how many tickets do the students still need to sell? It's not asking you how many they sold, it's asking how many are left. There are 2 ways to do this problem. kind of start the same though. The setup of the strips is the same. What number goes in here? This one is for the 7th grade. So the 7th grade has 300 tickets. So that's the 100% for the 7th grade, right? So 300 is 100% for the 7th grade. 60%, this is another, again, it's a multiple of 10. So we'll split into 10 equal blocks. Again, they're always going to be 10% each. And this strip then, each block is going to be worth how many? How many is each block going to be worth, Michelle-Lise? The total is 300, and I'm splitting it into 10 equal parts. Each one is going to be worth how much? 30, correct, beautiful. Okay, so each one of these blocks then is worth 30. Now the trick in this problem is, the question is not asking you, what is 60% of the number of tickets? It says they've already sold 60%, and they're asking for how many do they have left to sell. So you can do this two ways. How many blocks am I going to highlight? Kenny? Okay, I can highlight 6 blocks. 1, 2, 3, 4, 5, 6. And this is going to tell me how many tickets they sold. 60%. Which is the equivalent of how many tickets? 6 of these blocks, so that's how many tickets? 180. 6 times 30. Whoops, let's use the 10. Okay, so this is 180. Is that the answer to the question? No, that's how many they sold, right? So the question is asking how many do they have left to sell. So you could have just counted these blocks here, okay? And that would give you the total. Or you could subtract this 180 from 300, right? But it's kind of easier if you look at what's left. Stop. If you look at what's left, right, that is how many then that they have to sell. So the answer is that they have 120 tickets left to sell. So sometimes it's a it's 100% minus the number that they give you. You have to watch out for the question. Okay? Good. This is doing percent problems with a strip or a bar diagram. I think it's called strip in IXL. Okay? One other follow-up here. A lot of times you're given percents in a pie graph or a circle graph. This question says, this shows the result of a survey asking 500 teens about their allowances. How many did not receive between $10 and $20? Be careful when you are reading any question. Not asking how many did receive between $10 and $20. That would be this, 75%. They're asking how many did not. So what percent of the group is that? Roman? 25%. Okay? So this 25% is what I'm trying to find. The 25% of the what? Of the total. And the total is 500 teens. That's your total. So when I make my bar diagram, I always start with 100%, 100% bar, and that equals the total number of teens, which is 500. When I'm looking for 25% or 50% or 75%, I don't split this into 10 equal parts. I split it into 4 equal parts. Each one is 1/4 or 25%. Right? 4 equal parts on the percent bar. Each one is worth 25%. Right? 4 quarters makes up $1. 25 cents times 4 equals $1. All right, so then what is each one of these blocks going to be worth on the teens side? Roman? You might not be able to do this one in your head. You kind of should be able to. So half of this is how much? There, how do I figure out what each one of these boxes is worth? I've split the total into 4 equal parts. 500 divided by 4. Kenny?
125.
Kenny, see up here it says no calculator? Just for the record, I see that you have the calculator to get that answer, okay? How do you do this in your head? Well, half of 500 is 250, and half of 250 is 125. So, yeah, can everyone do that in their head? Maybe not, okay, but, so each one of these is worth 125, 500 divided by 4. And again, you don't have to write in all these numbers, but now I shade in the amount that I'm looking for, which is 25%. So that's one of these, which means it's one of these. So the answer is how many students did not receive between $10 and $20? 125 students or teens. Okay? So that's another type of problem. I don't think you're going to see any of these in the work that we're doing after this lesson. But we do have one other way to represent percent problems, and this one's not in your book, but you're going to see these problems in IXL. Okay? And this is by using a grid. Okay? So a strip or bar where you take the 100% and you split it up into equal parts. That's one way to visualize percents. The other way is to get a grid of 100 squares. Okay, 100 squares is 100%. Each square is 1%. And you can shade the grid in to show different amounts of percent. Because percent means out of 100, right? So this question says there are 60 players on the Elwood Middle School football team, and 30% were also on the team last year. Identifying the total is always one of the things you have to do. That's the total, which is equals 100%. And then what's the question asking? Well, what's 30%? For the players who were on the team last year is 30%. So how am I going to highlight this grid to show 30%? Alicia? Three rows across like this? 3 of these, that's 30 blocks out of 100 shaded in. That's correct. Okay, or you might want to do it, you could do it this way also. You do 3 columns, because each one is worth 10, either whichever direction you go in, right? Okay, so I've shaded 30% of this. That's the representation of 30%, 30 out of the 100, okay? But this 100 blocks represents how many players here in this problem? This 100 blocks is how many players? 60, the total amount. So this 100 blocks represents 60 players. I shaded vertically the other way. I shaded in columns, but it's the same thing, right? Okay, so the total grid represents the total, the 100%. The total grid is 60 players. That means that each of these columns is worth how many players? Kenny? If each of these was 10, that would be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so each column can't be worth 10 or else the whole thing would be worth 100. If the whole thing is worth 60, what is each column of blocks going to be worth? There are 10 of them, right? And the total is 60. So each one, is that you, Alicia, say 6? That's absolutely correct. Okay, each column is worth 60 divided by 10, or 6. So 6, 12, 18, 20, okay, so, or you could just put 6s on top of all these, right? So each column is 6 players because it's 1/10 of the total divided by 10. So the shaded area of 30% then is how many players? 18 players. So 18 players were on the team last year, 30% of 60. Each column or row is 1/10 of the total number. Last example. We took a survey of 70 students. This is actual data from the first day of school student survey. 70 math students, and 20% of them listed rap or hip hop as their favorite music. Were you one of them? Perhaps. Okay, 20%. What? What is hip hop? Like dance music? Kind of? I don't know, who's a hip hop person? A musical person, performer that you would know.
I know somebody else on the line.
I don't know who I would call a hip hop artist, but like Drake.
I was gonna say.
Yeah, like he's kind of hip hop, right? Okay. Great minds, Alicia, great minds. Okay, so 70 students were surveyed, and we're looking for 20% of them, all right? So we shade the grid to represent 20%. Shade the grid to represent 20%. So what am I going to shade in? Alicia? 2 columns or 2 rows, okay? So shade in, that's 20%, okay? The total amount of this grid is worth, right? Always look for what, identifying the total. That's this 70 students, that's the total. Okay, so this whole thing is worth 70. That means each column is worth how many, Riley? The total grid is worth 70 students, then each one of these columns is going to be worth how many students? Because I'm splitting it into 10 each column, right? There's 10 columns. Each one is worth 7. Okay, so this is 7, 7, 7, 7, 7, 7, 7, 7, 7, 7. That total is 70, right? 7 times 10. So how many students like rap or hip hop, Riley? Well, if only one of these columns was highlighted, that would be 7, but 2 of them are highlighted. 14, that's the answer, right? So 14 students. 2 columns equals 20%. Two columns equals 20% and also equals 14 students. So 20% is 14 students. That's how you use the model to find the percent of a number, okay? So that's it. You have 4 IXL assignments. All of them use these models, the strip models and the grid models.